Hi there, welcome to Whiteboard Math. Today we will cover the topic of matrices and matrix operations. I suggest you watch my video on systems of linear equations before watching this video because it will make a lot of things clearer. With that out of the way, let's get straight into this. A matrix is a rectangular mathematical entity consisting of numbers. There are m rows and n columns in the matrix, making a matrix a m by n matrix. In mathematics, we write this as m times n matrix. The matrix is usually denoted by a letter, such as A. Considering this, we can have a look at the example on your screen. Here you can see the matrix of size m times n. There are m rows and n columns, as you can see. The numbers in matrix A are called elements or entries. AMN denotes the entry in the mth row and the nth column. For example, A21 is the entry visible in the second row of the first column. Matrices can also exist when they only have one row or one column. Matrices consisting of only one row are called a row vector, and matrices consisting of only one column are called a column vector. Matrix X on your screen is a row vector and matrix Y is a column vector. Matrix X is a 1 times 4 matrix because it consists of only one row and 4 columns. Matrix Y is a 4 times 1 matrix because it consists of 4 rows but only one column. There is also the possibility that the number of rows m and the number of columns n are equal. An example of this is matrix D. Because m equals n, we speak of a square matrix of order n. Can you think of the order of matrix D? You have a couple of seconds to think of an answer. Indeed, matrix D is of order 2. The number of rows is 2 and the number of columns is also 2. Therefore, m equals n equals 2, making matrix D a square matrix of order 2. A square matrix also has a main or principal diagonal. In this case, this runs for A11 to AMN. When we look at matrix D, the square matrix, we can see the main diagonal consisting of entries A11 and A22. Remember, only a square matrix can have a main diagonal. This specific matrix is called an identity matrix because it only consists of zeros and ones, but I will dedicate a specific video to this later. Now consider a new set of matrices, matrix A and B. Matrix A and B can be equal under two conditions. Condition 1 is that both matrices have the same order, meaning that they both have the size m times n. In this example, we can see that matrices A and B are both size 3 times 2, meaning that they are of the same order. Remember that the size 3 times 2 matrix means that the matrix has 3 rows and 2 columns. Condition 2 is that the entries of both matrices are equal. The matrices A and B on your screen do not seem to be equal, but there are conditions on which they actually are. To be equal, we require 6 equations to be satisfied simultaneously. 4 has to be equal to t plus 2. 0 has to be equal to w minus 4. 2 has to be equal to 4 minus t. 3 has to be equal to 7 minus w. W has to equal 4 and t minus 2 has to equal 0. I give you a couple seconds to think of the answer on your own. If you need more time, just pause the video. Excellent! By solving these equations simultaneously, we find that matrices A and B are equal if t equals 2 and w equals 4. The answer is matrix C. In the case that matrices A and B had not been equal, we would have denoted this as A unequal to B, with the sign you can see on your screen now. I would like to stress that this is not the case in the previous example. We can also add matrices and multiply them by a scalar. Let's look at adding matrices first. On your screen you can see the matrix from our previous solution, matrix C, and the same 3 times 2 matrix which you call D for simplicity. We can add these matrices together because they are of the same order. We can only find the sum of 2 matrices if this condition holds. We can add 4 and 4 which equals 8, 0 and 0 equals 0, 2 and 2 equals 4, 3 and 3 equals 6, 4 and 4 equals 8, and 0 and 0 equals 0. We then find matrix E. As I said earlier, we can also multiply a matrix by a scalar. This is not very difficult. Let's go back to matrix C, which we have used before. We are going to find 0.5 C now. This is just the half of matrix C, so all entries in matrix C are divided by 2. we find 0.5c, which is this. We have now come to the end of the video. I would really appreciate it if you could like this video and subscribe to my channel if this video was helpful. It would help me out massively. Thank you!